Chapter 5.2, ASA Triangle Congruence. ASA stands for angle, side, angle. All right, that's very important. ASA stands for angle, side, angle, which I'll show you what that means in one moment. En español, ASA Triangle Congruence. Congruencia de triángulos ASA. La ASA significa ángulo, lado, ángulo. Ángulo, lado, ángulo. En un momento le enseño lo que significa eso. All right. So in this chapter, what you're going to be doing is deciding whether triangles are congruent using ASA triangle congruence. Vamos a estar decidiendo si triángulos son congruentes usando el ASA triangle congruence. All right. So let's first read what ASA triangle congruence theorem is. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Let me draw you a simple example that we can look at, and it'll make sense, okay? So let me say let's say we have this triangle DEF, and this triangle XYZ. Let's say this triangle, the angle for angle D is 40 degrees. Let's say this one's 30. And then this side measures 20 centimeters. And let's put the same information right here. All right, so let me explain what this chapter is about, what you're going to be doing, and this actually applies for the next few classes, because in the next few classes, everyone, you're going to be learning a different one like this. They're all easy. Like once you get the hang of it, they're all simple, very simple. Okay, so what this means is this. Let's say I'm trying to figure out whether this triangle DEF, is congruent to triangle XYZ. Congruent means all the corresponding sides are equal in both triangles, and all the corresponding angles are equal in both triangles. However, as you can see, there's information missing. I don't know what side DE measures, I don't know what side EF measures, and I don't know what angle E measures. And the same thing on this triangle. Okay, what the ASA triangle congruence theorem tells us is that if I have two angles in both triangles that are equal to each other, like the 40 is equal to the 40 and the 30 is equal to the 30, as well as the included side. The included side means the side that's in between angle 40 degrees and this angle that's 30 degrees. In other words, this side that's 20 centimeters. If the included side that's between these two angles is also congruent, is also the same, then with just that information alone, I could determine for sure that both triangles are congruent. Which means that even though I don't know what side DE measures, I know it has to equal whatever side XY measures. Same thing with EF, it has to equal side YZ, and same thing with angle E, it has to equal angle Y because of the ASA triangle congruence theorem. That's all we're doing in this class. So if you understood that, that's all you need to know. All right, give me 1 second to say that in Spanish, okay? Ok, así que si tenemos dos triángulos y queremos determinar si los dos triángulos son congruentes. Congruente quiere decir que los lados que corresponden tienen que ser igual y los ángulos que corresponden también tienen que ser igual. Ahora sí, se deben dar cuenta que me falta información porque yo no sé cuánto mide el lado DE, ni el lado EF, ni el ángulo E. Y es la misma situación en este triángulo. Lo que nos dice este teorema de ángulo, lado, ángulo es que si en dos triángulos tenemos dos ángulos que son congruentes, como el 40 y el 30 y el 40 y el 30, y el lado incluido, eso quiere decir el lado que está entre estos dos ángulos, también es congruente. Entonces, con solamente esa información podemos determinar que el triángulo completo es congruente este triángulo a este triángulo. Así que, por ejemplo, yo no sé cuánto mide el lado DE, pero por este teorema ya sé que tiene que medir igual que el lado XY. igual el lado EF no sé cuánto mide, pero sé que tiene que ser congruente al lado YZ. Y el ángulo E no sé cuánto mide, pero tiene que ser congruente al ángulo Y. Alright, now let's look at this example here real quick. It says find the measure of angle D. Encontrar la medida de ángulo D. Alright, so first of all, let's look at it quickly. As you can see, it has 45 degrees and 61 degrees. Okay, actually, before I do that, we got to calculate this angle that's missing here. This angle that's missing here. Okay, este ángulo B. Remember, by the triangle sum theorem, when you add up all the angles in a triangle, let me not put that sign. Let me just go like that. When you add up all the angles in a triangle, it always has to equal 180. All right, so let me put a lowercase b for this angle that I'm looking for. When I add up all those angles, it has to always equal 180. La suma de todos los ángulos de un triángulo siempre es 180. So 45 plus 61 is going to give me 106. 106 plus b equals 180. Now I subtract 106 from both sides. So b equals 74. Alright, so this angle has to be 74 degrees. Este ángulo tiene que ser 74 grados. Alright, so this is 74 degrees. Okay, why did I do that? Because now look, now you can see that this angle, angle B, corresponds to angle E. Angle C with angle F. That means that angle A is the same as angle D, 45 degrees. I could have also just done it in this one first, if I wanted to. In this one, I could have done 180 minus these two numbers, seeing that this is 45 degrees. So therefore, this side goes with this side. Anyways, what is the point of all that? The point of all that, well, actually, my bad. I just realized I said do this first. All right, guys. Sorry, I didn't read the I didn't read the instructions. All right, I just got this angle first. But to get this one, I would have just done let's say 74 plus 61 plus, let's say, lowercase d to represent this angle equals 180. Guys, don't we all do that when we buy something? Who bothers to even read the instructions? We just start opening it up and figuring it out. All right, that's what I do with math problems a lot of times, which is not always good, but whatever. All right, so when I subtract 135 and 135, I'm going to get 45 degrees. All right, so that's this angle right here. It's 45. All right. Anyways, okay, so once I know that, basically the whole point of this whole exercise was that for you to realize that these two triangles are congruent because of the ASA theorem, ASA triangle congruence theorem, because they have this angle, this side, and this angle equal to this angle, this side, and this angle. The two triangles are congruent by the ASA triangle congruence theorem. All right. Lo principal que se tienen que dar cuenta en este problema es que los dos triángulos son congruentes por el ASA Triangle Congruence Theorem. ¿Ok? Porque tienen el ángulo, lado, ángulo, ángulo, lado, ángulo congruente en los dos. Con solamente esa información ya sabemos que los triángulos completos son congruentes. Alright, let's look at this one. Alright, so look, without reading the instructions again, alright, I prefer to approach it that way, right? Let's find this angle that's missing right here, okay? El ángulo que falta aquí. Alright, so 110 plus 31 plus, let's call it lowercase k, equals 180. Alright, so I add these up. Whoops, 180. Alright, so now subtract 141 from both sides. Alright, so this angle is 39 degrees. As you could see, well, let's do the same thing for this one. Vamos a hacer lo mismo aquí. Alright, so 38 plus 31 plus, let me put lowercase p, equals 180. Alright, so I add these two up and I'm going to get 69 plus p equals 180. Subtract 69 from both sides. And I'm going to get 111. P equals 111. All right, so as you can see from looking at them, the triangles are not congruent because this angle does not equal this angle, and this angle does not equal this angle. Okay, so they're not congruent. So let's see what it says here. All right, the first thing they wanted us to do was find the measure of angle P. All right, so the measure of angle M is 31. The measure of angle N is 38. I'm just filling in the blanks. I already went over the important part. So this will be 69. So the measure of angle P is 111. Okay, now it says compare the angle measures and side lengths. Comparar las medidas de los ángulos y la medida, el largo de los lados. None of the angles in triangle M and P has a measure of 111. I'm pretty sure that's what they want me to put. M and P. No, my bad. This is silly. All right. Let me put the answer because I don't know what they want me to guess. 110. Okay. None of the angles in the measure of triangle MMP has a measure of 110 degrees. Therefore, there is not a sequence of rigid motions that maps this triangle on top of this triangle because they're not congruent. On your homework, I did not put any questions regarding, like there were some questions about what transformation do you do to this triangle to put it on top of the other triangle? Because if triangles are congruent, that means there has to exist a rigid motion or rigid motions that allow me to put one triangle on top of the other. I didn't bother putting that in the homework because I don't feel like that's the focus of this chapter, and I don't want to waste too much time with unnecessary problems. Okay, these are the types of problems that you're going to have on your homework at first, for the first couple problems. Okay, where you have to determine whether the triangles are congruent. Determinar si los triángulos son congruentes. Okay, so don't worry about the explain your reasoning part. I just want you to be able to determine whether they're congruent or not. Okay, so first of all, notice that it's two triangles put together. It's this triangle along with this triangle. Two triangles that are next to each other, okay? Estos son dos triángulos que están juntos. So I got that and I got this. All right, so first of all, notice that they both have this angle right here. This angle equals this angle. Angle B equals angle C. Ángulo B es igual a ángulo C. All right, now this line that's right here and right here, means that segment BD or side BD equals side DC. El lado BD es congruente al lado DC. Eso es lo que me dice esta rayita que está aquí. Okay, and now for this angle right here, it tells us that angle ADC is a 90-degree angle. Okay, if ADC is a 90-degree angle and this is a straight line always measures 180 degrees. So that means that angle ADB is also has to be 90 degrees for it to measure 180 in total because it's a straight line, okay? Si ángulo ADC mide 90 grados y esto es una línea recta, okay, entonces ángulo ADB también tiene que medir 90 grados para que en total la línea recta siempre mide 180 grados, right? So because of ASA, angle, side, angle, angle, side, angle, because of ASA, yes, these triangles are congruent. ASA. Por ángulo, lado, ángulo, estos triángulos son congruentes. Let me just tell you something. Coming up in the next few classes, we're going to be doing the same thing we're doing now, except they're going to give us different theorems, but they work the same way. Like there's another one that instead of being ASA, it's going to be SAS, side, angle, side. And then there's another one that's going to be SSS, side, 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 which we'll cover. They're all easy, but I'm just letting you know, like in the future, they're going to give you problems where you got to determine if they're congruent or not, and then you would write whether it's going to be ASA or SAS or SSS or one of the different ones that we're going to learn, okay? So just keep that in mind. They're all simple, though. It's nothing to worry about. Okay, así que esto sí es congruente por ASA, ángulo, lado, ángulo. Y en la clase que viene vamos a aprender la misma cosa, pero con diferentes teoremas, pero que son similares. Por ejemplo, hay uno que viene que es lado, ángulo, lado. Hay otro que es lado, lado, lado. Y los problemas que le van a dar son donde tiene que hacer lo mismo que acabamos de hacer y decir si es ángulo, lado, ángulo, o lado, ángulo, lado, o lado, lado, lado. Por hoy es solamente este. Ángulo, lado, ángulo. All right, let's look at number 6. Okay, number 6, the first thing I'm going to do is figure out what's the measure of angle R by doing 72 plus 38 plus lowercase r equals 180. All right, so I'm going to add up the 72 plus the 38, and that's going to give me 110. So 110 plus r equals 180. Now subtract 110 from both sides. All right, so r equals 70 degrees. R equals 70. Okay, así que este ángulo tiene que ser 70 grados. All right, now look at the other triangle. If this is 38, 72, and 70, there's no way that this one is going to be either 72 or 70. All right, so I could stop right there and say no, they are not congruent. Okay, as long as you realize that, I'm good with that, okay? For now, for these examples, okay? No pueden ser congruentes porque a la vez que sé que este ángulo es 70, si mira los números de este ángulo, ya es imposible que van a ser congruentes estos triángulos. Porque que falta, ya no es posible, los tres ángulos tienen que ser igual y es imposible, así que no pueden ser congruentes. Okay, now let's look at a few more examples. They're all the same thing. Okay, so in this one, if I look at triangle JKL, let me figure out what's the measure of angle L. La medida de ángulo L by doing 29 plus 121 plus L equals 180. So now let me add these two, and I'm going to get 150 plus L equals 180. Subtract 150, subtract 150. So the angle L is going to be 30 degrees. Ángulo L tiene que ser 30 grados. All right, so if this is 30 degrees, okay, so notice it says 29 degrees, 9.3 centimeters, and 30 degrees. And this triangle right here has 29 degrees, 9.3 centimeters, and 30 degrees. So yes, it is congruent because of the ASA triangle congruent theorem. Yes, ASA. If you realize that, that's all you need to know. All right. Sí son congruentes por el ASA, ASA triangle congruence, o en español ALA, ángulo, lado, ángulo. All right, let's look at the, oh, and by the way, it doesn't matter that the 29 and the 30 are flipped, because this could be a reflection. The triangles are still congruent. No importa que el 29 y el 30 cambiaron de lugar en este triángulo, porque puede ser una reflexión que le hicieron a este triángulo. Todavía son congruentes. All right, let's look at number 4. So let me start with the top triangle and figure out what's the measure of angle F. 68 plus 81, excuse me, plus lowercase f equals 180. All right, so when I add that up, I'm going to get 149 plus f equals 180. Subtract 149, subtract 149, and I'm going to get 31. So the measure of angle F has to be 31 degrees. All right, so as you look at that one and look at this one, that's it. It's impossible for them to be congruent. Okay, the triangles cannot be congruent because they're not gonna. The angle measures do not match up. Okay, ya se puede ver que no pueden ser congruentes porque la medida de los ángulos no va a ser igual. Let's look at number 5. All right. Number 5, let me do first triangle PQR and figure out what's the measure of angle R. So 34 plus this angle right here, angle Q, is 90 degrees. Plus lowercase r equals 180. Let me add these up, and I'm going to get 124 plus r equals 180. Subtract 124 from both sides. And I'm going to get 56 degrees. All right, so the missing angle is 56 degrees. And that's pretty much it. With that, you could tell that there's no way that these angles could be the same. So it's also not congruent. A la vez que sé que este ángulo es 56 y miro que este es 58 y este aquí es 34, ya es imposible que los ángulos sean igual, así que no puede ser congruente. Alright guys, number 6. Number 6 is an easy one to make a mistake on. So please pay attention to number 6. El número 6 es fácil de hacer un error. Okay, so on number 6, let me first figure out the measure of angle L. Okay, the measure of angle L. Let me figure that out first. Alright, so this angle is 90 and this one is 73. So 90 plus 73 plus angle L has to equal 180. 90 plus 73 is 163 plus L equals 180. Now I subtract 163. So angle L is 17 degrees. Alright, 17 degrees. Ángulo L es 17 grados. Okay, now, segment JK is a straight line. And a straight line always measures 180 degrees, right? So if angle LMK is 90 degrees, then that means that angle LMJ also has to be 90 degrees in order for JMK, which is a straight line, to equal 180. In order for angle JMK, which is a straight line, to equal 180, this also has to be 90 degrees. So 90 and 90. That didn't come out too pretty, but that's a little box. Okay. La línea JK es una línea recta y ángulo LMK mide 90 grados. Ok, eso quiere decir que ángulo LMJ también tiene que medir 90 grados para que ángulo JMK, que es una línea recta, ángulo JMK mide 180 grados, porque una línea recta siempre mide 180 grados. Okay, now for the important part. Here's the part that I want you to listen to because it's easy to mess it up and to not see it. Okay, yes, this triangle is congruent because of ASA. And if you don't see it, let me show you how, because it's easy to miss. Okay? First of all, notice that they have this angle, this side right here that they have in common. Both triangles have this side in common. So angle, side, angle, and on the top triangle, this angle, this side, and this angle. They're equal in both of them. They're congruent. I'll say it again. This 90-degree angle, side ML, along with this 17-degree angle, is equal in both triangles. In this one up here, it's this 90-degree angle, the same side that they have in common, side ML, along with this 17-degree angle. So they are congruent by the ASA triangle congruence theorem, okay? Así que, let me just say that in Spanish. Sí son congruentes porque tiene un ángulo, lado y ángulo en común, que son congruentes en los dos, ¿ok? Si miramos el triángulo que está abajo, triángulo MKL, ¿ok? Tiene este ángulo de 90 grados, este lado que los dos triángulos tienen en común, el lado ML y este ángulo que mide 17, son congruentes a este ángulo que es 90 grados, el lado que tienen en común, lado ML, y este ángulo que es 17 grados. Alright, now that we're done with that, okay, the only thing left is to go over some quick proofs that are going to be on your homework. They're actually easy, okay? They're easy. Okay, algunos pruebas que son fácil. Okay, remember that the first thing you always write is the given information. Okay, so it says given that the angle MQP, so look what I'm going to draw to make it easier to understand. Angle MQP, I'm going to put that line, is congruent to angle NPQ. Right, so angle MP, let me say that again. Angle MQP is congruent to angle NPQ. All right, and look at this one over here. Angle MPQ. Now look, I'm going to put 2 lines on that one. That one's going to be 2 lines. Is congruent to angle NQP. I'm going to put 2 lines over here. So this angle equals this angle, and this angle equals this angle. Prove that the 2 triangles are congruent. Prove that the triangle, notice that these have the symbol for an angle, all of these, and this has the symbol for a triangle. So now they're talking about the triangle. Prove that triangle MQP is congruent to triangle NPQ. I know the answer is there. Just give me 1 second and I'll get to it. Let me just say that in Spanish. En español, okay, primero te dan la información que ángulo MQP es congruente a ángulo NPQ. Okay, para esos ángulos le puse solamente una rayita. Así que este ángulo es congruente a este ángulo aquí. Y te dice aquí que ángulo MPQ es congruente a ángulo NQP. Para eso le puse 2 rayitas. Así que este ángulo es congruente a este. Quieren que comprobamos que el triángulo, ahora tiene el símbolo para triángulo, MQP es congruente al triángulo NPQ. Alright, so the first thing they put in lines 1 and 2 are what I said you always put at the beginning of any proof, the given information. Alright, so the first thing you always put is the given information. Lo primero que siempre se pone en una prueba es la información que te están dando, el given, lo que dice given. You just put the statements and the reason is always given. La razón siempre es given. Okay, now look. This chapter is on ASA, so these problems are about proving something using ASA. We already got the angles are congruent. The only thing missing is the side, this side. Okay, and look how they're proving it. Okay, segment QP is congruent to segment QP using what reason? The reflexive property of congruence. Look, you probably already forgot because it's been a few lessons since we saw that, but when we saw it, I told you guys, I mentioned that it comes up a lot. And this is how we end up using it, okay? Whenever you put that a segment is congruent to that same segment, it is always going to be the reflexive property of congruence. The key word to remember is this, reflexive. If you just remember that, the rest it'll be multiple choice. It'll be the only answer that says reflexive anything, all right? And the way you could remember is, the way I think you could remember is just imagine that word is kind of like reflection. When you look at your reflection in the mirror, it's like you're looking at the same thing. I don't know if that helps you. That's the only thing I can think of to try to help you remember. But it's always going to be the reflexive property. Now, once we've done that, okay, look, let me take you through the logic here. We already proved that the 2 angles are equal. And this included side, the side that's in between the 2 angles, is equal. That's all we need to prove what we needed to prove, which is that the two triangles are congruent using the ASA triangle congruence theorem. Listen, these questions are always multiple choice, so the program is guiding you through it. So it should be pretty easy to figure out, guys. It's not going to be difficult, trust me. Okay, así que en español, ya lo primero que comprobamos, lo primero que escribieron en la prueba es la información que nos dieron. ¿Ok? Si ya tenemos, ya sabemos que este capítulo se trata de ángulo, lado, ángulo. Así que si ya sabemos que los 2 ángulos son igual, son congruentes, lo que nos falta es el lado este que tienen en común, que es lo que escribieron aquí. Segmento QP es congruente a segmento QP, que los dos lo tienen en común. Así es como se escribe. Y siempre cuando tienen esta situación, un segmento congruente al mismo segmento, siempre la razón va a ser la propiedad reflexiva. Eso sale mucho durante el año. Estos problemas siempre te van a dar las opciones para la respuesta, así que es fácil de hacer, no tienen que memorizar nada. Pero sí necesitan recordarse esa palabra porque va a salir mucho y siempre es en esta situación. Pueden pensar de la palabra reflexión. Cuando uno se está mirando la reflexión en un espejo, es como si está mirando la misma cosa. Yo no sé si eso lo ayuda, pero pueden pensar de esa manera. Pero siempre va a ser la propiedad reflexiva y eso sale mucho. Ahora, ya que comprobamos que los 2 ángulos son igual o que son congruentes y el lado que tienen en común son congruentes, ya con eso podemos comprobar lo que nos dijeron al principio que tenemos que comprobar. Que un triángulo es congruente al otro por ASA, por el ángulo, lado, ángulo, teorema de congruencia de triángulos. All right. So look, here's one. I'll fill it out. Okay, so the first information they always give you is the given information. Lo primero siempre es given. Angle A is congruent to angle C. It says it right here. Ángulo A congruente a ángulo C. Next one, E is the midpoint of segment AC. That's right here as well. E is the midpoint of segment AC. That is also given. All right, number 3, segment AE is congruent to segment CE. Let me look at those. Segment AE is congruent to segment CE. Let me think for 1 second. Oh, got it. For a second, I thought I was going to have to look at the answer. All right, look. That is going to be the definition of a midpoint. Okay, because once they tell us that E is the midpoint of segment AC, if E is the midpoint of this segment, that means that this segment has to be congruent to this one. Because if this point is exactly in the middle, this segment equals this segment. And the reason they give, I read this in a book once, that a lot of times the reasons are like what's here, you end up putting here. Something like that. You know what, forget I just said that because I think I said it wrong. All right, but basically, once they told us that E is the midpoint of AC, that means that segment AE has to be congruent to segment segment CE, because that's the definition of a midpoint. A la vez que nos dicen que E es el punto que está en el medio del segmento AC, eso quiere decir que el segmento AE tiene que medir igual que el segmento EC para que este punto esté en el medio. Así que la razón sería la definición de un midpoint, del punto que está en el medio. Again, that'll be multiple choice, all right? So you'll be able to figure it out. All right, now angle AEB is congruent to angle CED. Let me erase all. AEB, which is AEB is this one, is congruent to angle CED. Before I write it, can you figure it out mentally what that must be? Look at it, it's pretty obvious. Angle AEB is congruent to angle CED. It starts with the letter V, like victory. ¿Ok? ¿Qué tiene que ser eso? Para que ángulo, ¿cómo se llama eso? Cuando ángulo AEB es congruente a ángulo CED y están así. Vertical angles. Vertical angles are always congruent. Now the correct answer probably might say something like vertical angles theorem or something like that, but I'm just going to write vertical angles. All right? And then the last one, we could prove that triangle AEB is congruent to triangle, let me try that again. Triangle AEB is congruent to triangle CED because of ASA. Why ASA? Because look, at the beginning, I didn't write it down here, I should have. At the beginning, they told us that this angle equals this angle. Then because this is the midpoint, that means that this side equals this side. And then because these are vertical angles, this angle equals this angle. Al principio nos dijeron que ángulo A es congruente a ángulo C. Y nos dijeron que E es el punto en el medio del segmento AC. Así que eso quiere decir que este lado, el segmento AE, es congruente a este lado, el segmento EC. Y estos dos ángulos tienen que ser congruentes porque son ángulos verticales. Así que ángulo, lado, ángulo. Angle, side, angle. Let me show you the correct answer. All right, pretty much what I wrote. All right, and then last, there's like 1 or 2 more examples. For the sake of time, I'm just going to show the answers on this one, right? So at the beginning, they write the given information, which was angle JLM is congruent to angle KML. JLM, which is all of this, I'll put one line, is congruent to KML, which is all of this. And then for this one, angle JML. Wow, man, they really make this difficult for me to draw on top of. Okay, let me use a different color. All right, so angle JML, I'll use 2 little blue lines. Notice that it's just for this part. It does not include this other part right here. Is congruent to angle KLM, which is this little part here. That didn't come out too good, but whatever. All right, so you know what? If I separate them, it's easier to see. If you separate them, we could study it easier. L J M K M L. All right, there you go. All right, so angle JLM. This one is congruent to angle KML, and angle JML, which is this one, is congruent to this one. So look, the only thing that they need is the side that's in the middle. They both have it in this figure. They both have it in this diagram. They both have this side right here in common. En este diagrama, los dos triángulos tienen este lado aquí que estoy escribiendo arriba de este lado en común. That's why they wrote number 3. Segment LM is congruent to segment LM due to the reflexive property of congruence. And once you show that, then the two triangles are congruent due to ASA triangle congruence. Alright, this is just an example with the answers there. Guys, I'm going to leave this on there, and just for the sake of time, you could look at this if you have a similar question on your homework. Si tienen una pregunta similar en la tarea, pueden usar esto para guiarse. And I think there's one more example here. Yeah. Aquí hay otro ejemplo también. For the sake of not making this video too long, guys. Alright, so I'm going to end it there. Your assignment is in the student portal, and it's due by 6 a.m. the next day that you have my class, okay?